Okay, lovely. All right. Just go ahead and continue. Yeah. Hi, everyone. This is Aishwarya Iyer. I am the Assistant Co-Director of the Community Building and Network Expansion Committee of the PSA. If you don't know about the PSA, we are a group or a global lab network that does a generalizable psychological science. So we conducted large-scale studies in psychological science together across the globe with multiple labs. It's super fun, and we try to make sure that this is collaborative and this is open science-based. And today, as part of our community building initiative, as part of South Asian Journal Club, we have Munna and Pooja from Psych rstats Club. And we're so happy because we're hoping to create a community and sort of establish outreach by making sure that all of us can build skills together and also find people and buddies that we can cry about R with together. So thank you so much for Munna and Pooja for agreeing to do this, and I'm going to hand it over to them to introduce themselves and to tell you about all the wonderful things they do.
Okay, thank you so much, Aishwarya. And so, hi everyone, thank you for joining. And I want to thank South Asian Journal Club for organizing this and inviting us. It's really exciting to be here today. So to quickly introduce myself, hi, I'm Pooja Kulkarni. I did my MA in Applied Psychology from University of Mumbai. I'm the founder of Psych rstats Club. And today I and my core team member Munna, we will be covering how to get started with R Markdown and what are its benefits. And before I begin with my part, I'll also invite Munna to just quickly introduce himself. And after that, I'll jump right into my part. Munna, over to you.
Right. Hi, everybody. I am Munna Arshini. I graduated from Christ University with a bachelor's in psychology. I belong to the Banargata Road campus. So if anybody from Christ are there, it is an absolute pleasure to be back. And it's my first time being a resource person to a crowd from Christ. After I graduated in 2021, and I'm currently a research intern at Axonet Brain Research Laboratory, Bangalore. And I am also remotely working as research assistant for Stanford Psychophysiology Lab and Many Babies Consortium, which is a big team science group. And I am most importantly a core team member of Psych rstats Club. And I'm absolutely delighted to co-host this session with Pooja, the founder of the initiative. Pooja, over to you.
Okay, thank you so much, Munna. And all right, so without any further ado, I'll just get into my part of today's workshops. So I'll just start sharing my screen. Okay. Is this our studio screen visible to everyone?
Yeah.
Okay, great. So I'll just quickly first introduce what is R Studio and then explain whatever you see here in front of you right now on the screen. So to begin with, R is the programming language, which was developed for statistical computing, which means that it is very helpful when you're trying to analyze your data. It has many packages, which makes analysis very easy. Especially when it comes to social sciences, many people use this for analyzing their data. And so this R is a programming language, and R Studio is the IDE, which is Integrated Development Environment, which means it's the software which makes coding in R much more easy and fun to do. So the screen you see in front of you right now, this is the R Studio screen. And in R Studio, you will be coding in R. So I'll quickly explain what these different sections of the screen do. So, okay, when you first install R and R Studio, this is what you will see. Also, not many of you might have installed it already. So first you can just go on this link to install R. So what you can do is just quickly copy this link, and don't worry if you do not have the link right now. We will be sending over this file to you so you can just copy paste these links. So this is the CRAN website, you can just open this here in your browser, and here you can download R. So this is what you will see when you copy paste this link. Just go over here and this is the page you will see for R. So you have to download R from here. And you have to select what is your operating system. Because I have Windows, I will click on download R for Windows. If you have Mac, you can choose this. So when I click here, you have to go on this because it install R for the first time. So just click on this and then download R for Windows. And once you click here, it will start getting downloaded. Because I have already downloaded it, I'm not going to download again. All right. So after you download R, go to the next link to download R Studio. So this is the link for R Studio. And once you open this page, come on this button to install R Studio. Because you have already installed R, don't again install it here. You can just start with this button. And when you click here, it will start getting downloaded. I'm going to cancel because I already have downloaded it. So the exe file gets downloaded, and to install it on your PC, you have to just click on the exe file and the setup wizard opens up. And then it will prompt you what you need to do in order for it to get installed on your PC. Mostly you just have to click on next, finish. So the setup wizard will guide you properly to install it. And once R Studio is installed, you will see this icon. You can see this R icon here, right? You will mostly find this icon in your program files, or you can search for R Studio over here and you'll find this. And then when you open it up, you will see a screen like this. This is the R Studio screen. But for you, it might look something like this because you have installed it for the first time, and it might be white for you because that's the default color. So when you see this screen, in order to start coding, you need to create a R file where you can type your code. So you can create different types of files here. People usually code in R using R script, R Markdown. So for now, you can make a R script file. So in this, you can start typing whatever code we discuss here. So for example, you can type 2 + 2 over here and just run this. And in order to run this, you can click on this run button over here, or you can press on Control and Enter on your Windows, or you can press Command plus written on your Mac. And once you hit this, you will get its output in the console pane. So what you did here, you coded this line. So this is the source pane. Whenever you type something, whenever you code something over here, this file you can save. So whatever you type, this is called the source pane. Whatever you type in this pane, you can save it later and access it again. The output for whatever you type in source, it will appear here in the console pane. But so along with the output, console also lets you quickly just try out codes. For example, you can also type 2 + 2 over here and run the line. So you will get output in console itself. So when you type the code in console, you can still get the output, but you cannot save the code in console as a separate file. So whenever you want to save something, make sure you create a file and type here in the script the source pane and then save it. So this is the source pane, this is the console, and this is the environment pane over here. Environment pane is where you will see all of your data or objects that you create in R. So whatever you import your data or any variables or objects you create, it will appear here in the environment pane. And below it is the output pane. This is where you will see whatever plots you create, or if you want to install any packages, you can see this packages tab. Munna will explain more about this packages during his part. So these different panes have many different functions, and as you start coding, you will get a sense of what these different panes do. Okay, so whatever codes we discuss, you can just start typing it here. But what we have prepared for this session, this is a R Markdown file. So Munna will also explain what exactly is R Markdown. But for now, you can just remember that R Markdown allows you to combine this code along with the text. So up here, I have just written explanation of the code here. So this is the actual line of code. Whatever is in between these brackets or quotes, this is the actual line of code. And to run this code, I click on this green button. Okay, so we looked at what the different panes in RStudio do. Now coming to what you will be doing with R most of the time. So you will mostly be using R to analyze your data. And as a beginner, you want to get started with some basic, like simple data sets on which you can practice your analysis on. So R is amazing because it also has some beginner friendly built-in data sets which you can use if you just want to practice or try out something. So these built-in data sets do not require you to download any other file separately. These are built into R, and to access these data sets, you just need to like type a few lines of code and you will be able to access it in R itself. So in order to view what inbuilt data sets R has, you can just type this line of code data and these brackets and then run it. So R will show you all the built-in data sets. So for now, I am going to work with this one built-in data set called Iris, which is a very commonly used one. So just note down its name. You can just directly copy its name. And once I know which data set I want to work with, and if I want to know more about it, I can type a question mark in front of the name and run it. Whenever you type question mark in front of something in R, it gives you more information about that thing. So because I type question mark in front of this data set name, I will, when I run this line of code, you can see I got more information over here in the help tab of the output pane. So here it says it gives measurements in centimeters of sepal length, width, petal length of 50 flowers of 3 species of iris. So it quickly gives a description of the data set. Now, once you got an idea of what the data set is about, if you want to know more about how big the data set is, you can use dim function. You can remember it as short for dimensions. So this dim function, when you type this, and inside you have to type the data set name. When you run this, you will get the number of rows and columns in the data set. So this is helpful to understand how big it is. So you get two values here. The first value is always the number of rows. The second is always the number of columns. So you get an idea of like how big this is. Now, if you want to actually view the data set, you can just quickly type its name and just directly hit run. So when you run this, you get the output here for the data set. So you see there are so many pages and you can actually see what the values are in the data set. For if you're trying this code in your R script file, the output will be printed in console. Okay, so this is how you view the data set. And if you just quickly want to, so what happens is usually data sets are pretty big and scrolling through all the pages of data, it might take time. So in order to quickly get an idea of what kind of values there are in each column, so you can use this function, head function, and inside you have to type the data set name. So what this function does is it gives you only the first 6 rows and all of the columns in the data set. So you get a gist of what the data looks like in for each of the variables. So when you hit run, you will only get the first 6 rows now. See, only first 6 rows. Okay. So we saw how to view the built-in data set and how to access it. Now, but when you are actually coding, like in R, most of the time you will be working with your own data set. As a researcher, you will be using R mostly to analyze your own data. And in order to analyze your own data, you need to import it into R. Now, the way to do this is actually there are several different ways to import your data into R. One of the way is to use this import dataset option here in the environment tab. So when you click on this import dataset option, you can choose what file type you want to import. If you want to import an Excel file, you can click here. Or if you want to import a CSV file, you can click over here, text reader. So for importing Excel file, I'll click here and I'll browse whatever file I want to import. And over here, I'll just choose whatever file I want to import. So this is the Excel file that has the data. So once I have selected it here, it will give me a preview and I can click on import here to just quickly import it into my environment. So once you can see it here, that means you can start using it in your code. All right, so this was one way to import your Excel file. There is another way to do it by actually writing lines of code. Now, actually writing lines of code in order to do the same thing is helpful when you're passing on the file to someone and you want them to know that this is where you are importing your data set. So that way it is recorded in your file that you are importing data set here. So in order to do that, in order to import your data set by using code, you need this read Excel function. So also, what I mean by function is each function in R is like a line of code which has a specific purpose. And as you start using R, you will quickly, like, you don't have to memorize. It will become like second nature to you. You will just remember what different functions do. So, and if you cannot remember, you can just simply Google what some function does in R and it is pretty well documented. So for now, just know that if you want to import an Excel file by writing this line of code, read Excel, by using this function, you can like import an Excel file, but you cannot directly type this function and run it in R. So in order to use this function, read Excel function to import an Excel file, you first need to install the read Excel package. Because this is not something that is there in base R. This has been built into this read Excel package, and Munna will explain more about what the read Excel package, he will explain more about what packages are in general. So you will understand more about it then. But for now, just know that in order to use this function, you first need to install this read Excel package, and then you need to run this line of code library read Excel. And then you have to type this line of code, read Excel. So what this does is it tells us that you want to import an Excel file. And inside this read Excel, I have also written file.choose. So this opens up a dialog box in order where I can choose the file that I want to import. So this will open up a box which would allow me to choose the file that I want to import. And this sheet equal to 1, it means that it tells her that whatever file you choose, in that you want to import only the first sheet, because usually Excel files have like multiple sheets. So you can choose whatever sheet from it you want to import. Because I want the first sheet, I will type sheet equals to 1 here. Now, when I run this, this is what I get. So see, automatically it opened up this box where now I can search for my file. And I will select the same file and click on open. And here you see this DF has been created. It's the same data set. It has 100 observation of 4 variables. It's the same thing, but this time it is stored as DF. This is because here we have used the assignment operator. So this means assignment operator in R is basically like you can store something in another object. So whatever comes after this assignment operator, it will get stored in whatever object or variable you create before it. So because I have written DF before this read Excel and I have used this assignment operator, this data set will get stored in DF. So here you see this DF has been created. And after this, every time I want to access the data set, I can just refer to it as DF. So if I again want to view the first 6 rows, I can again use this head function, but instead of using the data set name, I can just refer to it as DF. So when I hit run, I will again see the first 6 rows. So here you see, this is the data, the first 6 rows of the data set. Now, this was how you import the Excel file. If you want to import a CSV file, which is another common type of file that you see, if you want to do that, you can do that by using read.csv, this function. Now, you don't have to install any other package separately for using this function. You can just simply type read.csv, which tells R that you want to import a CSV file, and again file.choose in order to open up that box where you can select what file you want to import. So when you run this line, it will let you import. You can select whatever file you want to import here. So here you see df2 has been created. So from now on, you can refer to it as df2, and when you run head df2, it will give you the first 6 rows of the data set. All right, so this was my part. I showed you all how to install R and R Studio and how to import your data set, and also how to use the built-in data set. Now, Munna will be showing you all how to conduct some basic statistical tests in R, and he will also introduce R Markdown. And okay, thank you for listening today. And if you have any doubts or questions, we will also have time for some Q&As, or you can also email us later. So yeah. All right. So this was all about my part. Thank you so much, everyone. Munna, over to you. I'll just stop sharing my screen.
Hey, I'm just going to jump in quickly to say that the beautiful R Markdown that Pooja and Mona will be working you through is something that we can share with all of you a little bit later. So at the end of the session, that is something that you can walk yourself through again. And I'll also be sure to share the socials of Psych rstats so that you have a much more connectable community. Over to you, Mona.
Right. So I just want to confirm whether my screen is visible.
Yes.
All right. Okay, perfect. So I'll just run through something that Pooja has mentioned in her presentation almost at the end about assignment operator. So in R, we can assign anything to anything, basically. So basically, you can rename a certain or data point or a certain value or anything as such onto a certain other word. So here, like, for example, you can see I'm trying to assign the number 5 to X. This is a very basic algebraic equation that we're going to try, like which you can see it over here. Okay. So for that, first we are saying the X value is 5, and then we are saying 5, then 10 is a Y value. So using this X and Y value, now we can just do a bunch of arithmetic operations. First one is X plus Y. So just going to do this. I'll explain what this is later, but so the code ends the moment we put these 3 marks. That's the point of putting these 3 marks. So when I press the hit run, it will show me the result of X plus Y. So here we can see the value of X was, of course, 5, and then Y was 10, and the sum of it is 15. So, and next, if we try product, it's going to be X into Y. So you say you're assigning the word product to the value X into Y. And similarly, mean of X and Y is being given. So I will just run it together. So now we can see all together in the value, the pane actually. So, 1 second. I'll just remove this for the time being. All right, so when we hit run, what happened was we got the sum value of 15 and the product value of 50. For mean value, however, the result appears onto this console panel. So here you can see the value. 1 second, I'll just direct. Yes, so here you can see the mean is 5, and the answer to these just comes up in this environmental area. The reason why that has happened is because we haven't assigned the mean value to a certain word. So let's say if I want to assign the word again, let's say another word, which is average. Average is synonym for mean. And if I put the assign operator, and now if I check it, see here, you can see the average value, which is the mean value of X and Y, which is 5, right? So now moving on to how to load packages. So R is of course a programming language like Pooja mentioned, and we all know that as well. And in R we use a bunch of packages. And in by packages we mean one package will have so many functions inbuilt inside it. So depending on your genre of work, we have different packages. One such package is called ggplot2. Ggplot2 just simply means like it's a set of functions put under the name ggplot2 for plotting stuff. So first, if you have never installed a certain package, the of course the code will be like install dot packages, and in double quotes you have to put what the package name is. See, I already have installed this package, but just in case, like we for the session, we can just install it once again. When you run, if you have already installed the package and you hit the same code again, what happens is the latest code will most probably get installed again. So that's one another way of keeping up with the packages as well. So here, when I hit install packages, see it's from the respective server. The latest version of GG plot2 has been installed. And once you have done installing the package, you just have to use the code library and in bracket the name of the particular package. So what happens is whenever you type library option, like when you type library, automatically the option comes to choose library, and it will open and close a bracket. Inside this, you can put whatever you want to put. So I'm going to put ggplot2. So if you have installed, then this option will come for you. If you have not installed, it means like that you need to install it first before trying to bring that package into use. So yeah. Now I think I'll just move on to the next one, which is descriptive statistics. Since we all are people who involved in research, learning some descriptive statistics first as a beginner would be really great in R. Just like how we did this basic arithmetic functions, we can also do a bunch of mean, median, mode, minimum, maximum value and stuff. So first, this will be done based on the iris data set that Pooja mentioned about. So just in case if anybody need a quick preview of iris, I will just load it here. Yeah. So iris, okay, this is how iris looks. Iris has a column called sepal length, sepal width, petal length, and petal. These are the values that are in numerical nature, and this is some categories. So here we can see setosa, we can see a bunch of other as well. Versicolor, and we have Vojnica. So these are three categorical variables. This is a categorical variable, and the remaining are all numerical variables. So using that, let's just do some exercises. First, to calculate mean of a certain column within the particular data set, what you do is you enter mean, then automatically, like I said earlier, this is a function, right? So whenever you type something, it should ideally come automatic. See, since like this is a basic function, it automatically is imported. And so you click on this, and then you type the certain data set that you're working with. So if it was DF, let's say we put DF. Here, since we are working with iris, we'll put iris. And then what you put is you put $sign, and then you choose whatever you want to choose. So here I've chosen sepal length. So let's run the mean. So for this, I'll be using the shift plus command plus enter. When you put command plus enter in Mac, I'm using Mac device, it will automatically run the selected line of code or the certain code snippet that you have selected. If I just do not press on anything and hit command plus enter, what ends up happening is it will run the whole thing. But I don't want that to happen, right? So I'm just going to choose this and then put command and enter. For Windows, it is of course like the control key, control shift key, and the enter key, if I'm not wrong. If I'm wrong, just put it in the chat box, Pooja. And The mean of sepal length is what we need to know, and the answer is here. It is 5.9, sorry, 5.843333. Okay. Next, just do the same thing with median. You put the word median and put the same remaining code, and the same for minimum max. So now what we will do is we can just like hit the whole thing in one go. Sorry. Command and enter. So here we can see all the results. So the mean is again 5.84. The median is 5.8. The minimum value of sepal length in the data set is 4.3, and the maximum value is 7.9. And these are the things that you get over here. And of course, you can assign also if you want. Let's say I'll just assign to ABC. Okay, something I'm just going to assign and show you guys. This is another way to run the chunk. And now ABC value is 7.9. This is one way you can assign it. If you want everything in one table, there is another code which you can use, which is called summary. And then again, the brackets will open and you just have to enter the data set's name. So here, when we do that, what happens is it will show you the whole result. So this is for these codes were for a particular column within the data set. Instead, when you put this particular code, you will get everything. So for example, here you can see the minimum, median, mean, the minimum and maximum value, the first and third quartile of each column, sepal length, sepal width, petal length, petal width, and the species as well. Since here we do not have a numerical value, because if you remember, these were the categorical variables, it will show only a n value. So this also you can assign to a, you can use an assign operator and put it in, let's say, summary of iris. This can be done. Okay. Then, okay, so this didn't work. I will, okay. So for this, what happens is you have to put this card, I'm sorry. You have to put it as a data frame, then it will look as a data frame, sorry. Okay, there's some bug. Okay. I'll explain this later. We'll move on to the next topic, which is testing normality in psychological research. So, when we use normality, we need to know whether the data is normally distributed or not. For that, we use normality testing. There are two ways of normality testing. One is Shapiro-Wilk test, and the second one is Kolmogorov-Smirnov test. Shapiro-Wilk test is used mostly when you have, like, I think, different people have different opinions, but like generally, like when you have 100, 150, or like all those kind of number and value sample sets, you can use Shapiro-Wilk. And when you have a huge data set, you can use Kolmogorov. So here, what we are going to do is we are going to run the Shapiro-Wilk test on the sepal length component of iris data set and assign it to the word Shapiro underscore test underscore result. Or if you want to make it just simple, we can also cut this and make it Shapiro, just Shapiro also. Since I have done it, I'll just keep it like this. So this is easier for people to understand even after the session. So first, what will happen is, like I said, we will assign the result to the word Shapiro underscore test underscore result. And then to display this test result, we'll just type it just like that. Okay, so here you have the W value, which is the central value that you have to look at, and the P value of it. Here, as you can see it, the P value is 0.01018. For any normality testing, we would want it to be beyond the set P value, let's say 0.05. Here, this is below 0.05, which makes it to which will force us to reject the null hypothesis, indicating that the data is not normally distributed. And if you were to do Kolmogorov-Smirnov test on the same thing, the code remains almost the same, but just that instead of Shapiro dot test, we will put KS dot test. And here, what you need to do is you need to put these extra few components, which is P norm. P norm is like the probability normality. So that's what we wanted to mention, that we are looking at the normality based curve. And then we have to also add the mean value and a standard deviation value so that we can interpret it better. And the same has been assigned to KS underscore test underscore result. When you hit it, See, this is not a data frame, so it won't show us a table, but instead you can see it from here. So here the trickiest part is the p-value is said mentioned in the scientific notations, but in general, again the gist is that the value is very low. It's like it has multiple exponential value in the negative side, which means like it is having very small p-value, which again forces us to reject the null hypothesis. Moving on to the next one, which is correlations. Of course, we all use correlations to measure the strength and also the direction of relationship between two variables, whether there's a positive correlation or a negative correlation. So here, what we are going to do is we are going to do two things. One is the parametric way of doing it. Parametric way of doing it is, it means if the normality testing proves that the data is normally distributed, you do parametric testing. And if it comes like that, it is not normally distributed, then you choose a non-parametric alternative. So here for correlations, the parametric way is Pearson's product moment correlation. That is to compare that is to do correlation between any two variables that are continuous in nature. And the Spearman correlation is the one which is for the non-parametric version of the same thing. So here we're going to do that of sepal length and petal length. So this is one way of doing it. The first result is this, which is the Pearson's product moment correlation between the two variables. So here this one is this. The first code only gives you the value, the p value, and the second one is this is a Spearman's value of the same comparison, some two data sets, two columns. And when you do a second alternative code, what happens is this is a core.test code, and you mention which method you want in brackets. This one will give you a little more elaborate way of results. Here you can find the p-value, the t-value, and here the p-value is very low, which means like there is a significant correlation between the two. And the same for the Spearman way as well is being given. So this brings me to the point that there is no one single code in programming in general. One code will give you one thing, while the other code might be more efficient and will give you more details than the other. So it depends upon what you want. You can choose different codes. And now let's move on to another thing that will be very beneficial for us, which is the group comparisons. To compare two groups that are independent in nature, let's say we want to compare between, let's say, the performance in school number one in terms of, let's say, a dance performance, whilst the comparing that with a school performance in, let's say, in a college level. If you want to compare that, then you do independent sample t-test. So here, with respect to the example that we are following, which is the iris data set, to compare the sepal length based on the species name, species name, let's say, how to compare the sepal length of the setosa species flowers and versicolor set of flowers. For that, here it's a little bit tricky, but I will break it down the code for you. First, we need to extract the sepal length of certain species. So we have to group, or we have to just isolate from the bigger data set the values that belong to the setosa species, and then similarly for the versicolor species. So here what we have done is we have chosen iris, the sepal length column of iris. That is what this means. Within that, go to the same iris data sets, species column, and when it is double, here we put two equal signs, which is giving us the idea of equals. So here, then it's just like a matching operator for the most part. Let's just call it a matching operator. So based on this word, if this word is there in the species column of iris dataset, then pick the sepal length of that particular column. That's what this means. And similarly for versicolor as well. If it's confusing, I will explain it again later. And then once those two values are isolated from the bigger data set, now we can perform t-test wholeheartedly. So here we do t-test, t.test, and then add the value that we have added, the name we have added for these values. That is versicolor underscore sepal length and setosa underscore sepal length. When you do that, you get this assignment done, and then you display the result using the same thing, like we know. So now we have done it. So here what happens is there's a two sample t-test, and the t-value is given as minus 10.52, and the difference is 86.53, and the p-value is very low, which means of course means like it's very low. So which means we cannot find a difference between the two, right? And the same thing if you want to do a non-parametric way, since it's already assigned here, it will be in the in our window as well. So if it's not assigned, then we have to do it again. Okay. So imagine I have not done it before, and I'm gonna copy paste the same code here. Okay, so similarly, we actually isolate the sepal length value for both the species and then run Wilcox dot test and then assign it to Wilcox result and then display it. So that's what we're gonna do. Okay, here also see the p-value is very low, and the W value is 168.5, which again gives us the idea there is no significant difference, right? Now coming to another point. Another point is paired sample t-test. That is like comparing one component at two different time periods. So let's say like this is a scenario that I have created. So here, since we can't use iris dataset, we have to create a dataset. And this is how you'd create a dataset. So you put a name that you want, and then you put an assign operator, and then you put C. C is called combine. It's for combining a bunch of things that you're going to list inside the bracket. So we have listed these values. So the scenario, so I made the data set with this idea in mind of a pre-intervention and post-intervention. Okay, let's say before the intervention, the sepal width was so and so, so and so. And after the intervention, the sepal width is this. So now to do t-test, the paired sample t-test, what you need to do is it's it's almost the same as how we do it in terms of independent sample t-test. But here, instead, what we need to do is we need to also add the comment whether it's paired or not. So you put paired is equal to true, and then you run it. So now from this, here we can see the t value is coming as 0 and the p value is 1, which is like, because this data set is not normalized as such, and it's a very dummy data, we got a very weird result, but that's not going to be the case when you are doing with a real data set. Okay. And the same for Wilcox and sign rank test as well, which is the non-parametric version of paired sample t-test. And for that also, we do the same thing, just that the code is different. Instead of just t-test, it's going to be Wilcox.test. And the p-value is 0.5 and the v-value is 5, which is just, which is also giving us idea that this time maybe like it is different. Coming to, it's kind of wrapping up, and we are coming to the point that what is R Markdown. So Pooja and I are two individuals who are open to open sciences. We believe in open science and open learning. So R Markdown is one open science tool within the programming language R, and the software we use RStudio. This is a R Markdown is gives us an idea, gives us the ability to create a document which has a section of comments, code, and also put outputs. So here, like you can see, like for example, here there is a we can type something like here. See, we can type let's say here, I'm saying this is the heading paired sample t-test, and then I put the description of what paired sample t-test is, and then give some comments related to it. Then I can put a code snippet. So to start a code within R, this is what we do. So we can also okay, sorry, I will start with how to create an R Markdown. So since this is a Mac device, you will have the file option here, and then you create new file and create an R Markdown. So that automatically it will create one. You can add a title and stuff. So I'm going to put ABC and then create one. And here, if you will automatically get a template, and you just have to fill in however you need it. Generally, the idea is that you will have, whenever you want to code, you have to start with these marks and then put R in square in the jittery bracket, and then close it with the next operator. And whatever you put inside this will be processed as a code, and whatever you put outside it will be just put as a text. And in situations when you have plotting, let's say if I haven't included plotting in this, so imagine this is a plotting, the picture also will come right below it, so that whenever you send an R Markdown file to somebody else and they run it, they will get everything that you have put. That is the comments, the descriptions you have put, the values, the results, the images that you have added, that is the plotting that you have done and all those kind of things. Now let's come back to our file. So why R is important? R Markdown is important. Of course, the first thing is that R is a very free language, free programming language. You don't need any subscription or anything like that, which also adds on to the point that R Markdown is also free. And we can create reproducible code. So I personally use you go to previous research we conducted and go to their R code, and I can copy paste the same code and run the same test on a different data that I've collected. So let's say an American study has been conducted and I have an Indian data set. So if we need to compare that, like reproduce the same research, I can actually use the code that the source researchers has used and just run it in my R. But instead of their files, I have to just add my files. So that way we can reproduce more research. And the third is the transparency. So this is a good thing. If you have done something wrong, the person can point out, somebody else can follow back and tell you, okay, this is something that has been done wrong. Or if you want to actually make conversations about, okay, how did you carry out this research? Or let's say carry out this particular analysis. Why did you do this analysis? If you want to ask these kind of questions to the authors, you can always use this as a source code and tell them, okay, I didn't understand the code segment in this and this. So transparency is always there. That opens us to more questions, more ability to question people, ask doubts, clarify them, and also probably open up more conversations about a certain research project as well. And R Markdown is, of course, an efficient place to be at. Like, it's a document which will give you everything together. So it's like a one-stop solution to your research. So when it comes to analysis, you can keep one single document and you don't have to go through the hassle of having multiple documents for coding and also simultaneously keeping another docs file saying what this code means and stuff. So you can simultaneously do things and just go in a very seamless fashion. And of course, R Markdown are a dynamic documents, which means like if you want to keep adding stuff, you can always keep adding and resaving the same document. That is common to anything. It's just like how we have Microsoft Word. It's the same function. You can keep adding and just keep saving it. And you can always customize an R Markdown depending on how you need it. For example, now we have customized it this way that for example, we showed you the sample, right? The untitled ABC R Markdown that I just opened right now. That is a template that's been given, but that's just template again. You can customize it however you want. This is a customization we have done. Now you'll be wondering why these many hashed outs are there. It's for this. So here on the outline, you can see how the whole content of this particular R Markdown looks like. So see, these are kind of things that you can do in R Markdown to make your life easier as a researcher as well. And then coming to the next point, integration of visualization. Like I showed how to plot within R Markdown, you can also integrate visualizations. It's also making it easy for collaborating. For example, right now, this document has been first created by Pooja. Pooja has filled up her parts and then she sent it to me. And then I downloaded it and entered my parts. And then I sent it her back, the file back. So that way you can improve collaboration. This is just a simple example that I gave, but when it comes to research also, the same thing can be done. You can have international collaborations and analysis can be carried out together. If any corrections needs to be done, that can also be done through this platform. And data management is also very easy when it comes to R Markdown, because like how Pooja mentioned, adding codes to load files, you can also manage everything together. If you have a folder with a lot of cluttered documents, when you have these documents cited in your R Markdown, it's easy for you to go through and figure out which file was which file and what are the necessary files over unnecessary ones. And last and finally, it's for teaching and learning purpose. Since R Markdown is transparent and also very easy to collaborate with. When you're teaching analysis, it's easy because it's also easy to teach them as well. When you're teaching also, it's more easy because you can run assignments, you can show tutorials. Like this is a tutorial that we are showing. So when you are actually given an assignment related to data analysis, you can always give comments within the R Markdown and send the students back. That's an option that tutors might have or teachers might have. And while also same with assignments as well as group assignments, you can do your coding part and then send it to your friend, and the friend can do the remind. So that's also a collaborative way of doing it. And by the end of doing an having an R Markdown file, you can always save it. So if for saving R Markdown, you have to do knitting. The saving option is called knitting. This knit on save option is just to keep it up to date. It's like an auto save option. But actually, if you want to save it as, let's say, a HTML file, you can do that. If you want to save it as a PDF file, you can do that. And if you want to save it as a Word file, that also you can do. But I think Pooja will be showing you an example, or like we'll be sending the PDF version of this R Markdown file as well. So that time you will understand how elegant it looks by the end of it. So I think I'll just stop presenting now and I'll take questions for both me and Pooja will take questions, I think.
Awesome. Thank you so much, everyone, both Munna and Pooja. To everyone attending, if you have any questions, please feel free to leave it in the chat box, or if you'd like to unmute yourself, that's also okay. Yeah, any questions, all welcome.
I think there was a question in the chat about normality tests. I think they want to know more about the normality test that you mentioned, Manna. Can you just like elaborate more?
Yeah, so normality testing is a statistical test to know whether the data is normally distributed. So if you might know, like when a data is being plotted on a picture, we want the picture to look with a bell curve. So like whether the data is representing, uh, giving enough representation to each data points, that is low data points, high data points, the middle points, that is the question here. So the statistical test to find out whether it's normally distributed or how well it is following the bell curve, we do Shapiro-Wilk test or Kolmogorov-Smirnov test. Shapiro-Wilk test is done when the data size is small. When the data size is big, like let's say 400, like 200, 300, 400 and stuff, and beyond that, we would try to look at Kolmogorov-Smirnov test. I'm not very sure about the basic assumptions behind it, like by heart. If you ever have any questions, you could actually Google them as well. And one thing I would like to also add is when me and Pooja were learning R, we never had the option of chat GPTing our doubts and codes. Chat GPT is one way to understand what certain codes mean. So even today, when I go through certain researchers' complex codes, I might end up copy pasting the code to chat GPT and ask what it means. So people who have learned after the chat GPT era will have certain more easy control over how to learn them well as well. So please feel free to use that. And also, I think Pooja has built a bunch of resources, like the link to our resources page. So us at Psych rstats have collated a bunch of resources for starting a data analysis with R and installing R and carrying out certain analysis. So you would check that bunch of resources as well.
Okay, there is one question about doing PCA. Unfortunately, right now we do not have the time, but maybe in future something like that can be done. But thank you so much, and hopefully sometime in future. And also we do have like resources on conducting PCA.
Yes.
So on the sheet, I'm not sure if exactly it's PCA. If it's not there, we will surely add it. But if you also are there on our Slack, so we have the Slack channel where you can request whatever resources you want. So we will just send it along to you. So unfortunately, right now we don't have the time, but later on, maybe sometime.
Also, PCA is a little complex to carry out. Although in R it's easy, of course, but it's you need to know a bunch of stuff before jumping into PCA. And since we aim to work on an introductory for friend, I think that's something that we could learn through our Slack interactions. So we would love to have you join the Slack group as well.
Also, in order to join the Slack group, you can just quickly like send an email over here. So we will send you the link to join the Slack. So if you just send us a email on this, wait, this is the Psych rstats email. Just now I have put in chat. So if you just send us an email here, we will send you the link to the Slack group. Yeah. Also later on, maybe we can just send a link, send a common link maybe later on. Do you think that would be possible? Maybe with the drive link, another link to join the Slack, maybe something like that we can do.
So from the journal club, we tend to send a follow-up like email after we do these sessions. So if you would like to send me on email what all sort of information I can pass on to our attendees, I can do that.
Yeah, thank you so much. Yeah, that would be great. I'll email you later, whatever. Yeah, thank you. Is there any other question? I don't see any other questions right now.
And then I am just going to stop the recording here.
Okay, thank you so much. It was really fun to be here today.